All right, so in this section, we're going to be talking about the converse of the Pythagorean Theorem. So first, you got to remember that the Pythagorean Theorem was that if we have a right triangle, then a squared plus b squared equals c squared. And so when we do a converse of a theorem, that just means we flip it. And so the converse of the Pythagorean Theorem is that if the sum of the squares of the length of the two sides of a triangle is equal to the square of the length of the third side. So basically, if a squared plus b squared equals c squared, then the triangle is a right triangle. That is this theorem. So whereas before we had to have a right triangle and we would know that a squared plus b squared equals c squared, now if a squared plus b squared equals c squared, then I know my triangle's a right triangle. If it doesn't equal, then it's not a right triangle. And when you get up into geometry, you actually can tell whether it's an acute or an obtuse triangle. But that's more than we need to do here. We just need to be able to prove, is it a right triangle? So example 1, decide if the following is a right triangle and justify your reasoning. So our largest side, C is always the largest side. C is always, largest. That is the way it has to be. So, since this is my largest side, this is C. And from there, A and B doesn't, we'll call this A and that one B. So we're going to do A squared plus B squared. Oops, I put C. B squared. I like to put question mark C squared. Does it equal? Is it equal? And so we're going to do 6 squared plus 8 squared. Question mark 10 squared, because I don't know if it's equal, and that's why I don't like putting the equal sign. So 6 squared is 36, 8 squared is 64. Does that equal 100? Because that's what 10 squared is. 36 plus 64 is 100, so 100 equals 100. Check. And so our answer is yes. This triangle is a right triangle because 6 squared plus 8 squared equals 10 squared. Done. That's example 1. So, moving on to example 2. Our largest side is 6, so that's going to be my C. So we'll plug in 4 squared plus 5 squared, question mark 6 squared. So that's 16 plus 25, question mark 36. Well, 5 and 6 is 11. Carry the 1, 2, 3, and then that one we carry is 4. So we get 41 compared to 36. So it does not equal 36. And so our answer for this one is no. It is not a right triangle. Right triangle. Because 4 squared plus 5 squared is greater than 6 squared. Not equal to, but is greater than 6 squared. And so that makes it to where it's not a right triangle. It really is as simple as this. I know it just seems too easy. Mrs. Cartwright, we've already gone through 2 examples and we haven't even hit 5 minutes into the video. How can this be true? It is. It is just that way. I'm going to look at my sides. I know that 6.5 is my biggest side, so that's going to be my C. I'm going to plug 2.5 in for A, so 2.5 squared plus 6 squared, question mark 6.5 squared. 2.5 squared is 6.25 plus 6 squared is 36. And is that close to 6.5 squared, which is 42.25. So then we're going to take 36 plus 6.25, and we end up with 42.25. And so that equals 42.25. It says to justify our reasoning, so we're going to say yes, because 2.5 squared plus 6 squared is equal to 6.5 squared. That's our reasoning. It fulfills the obligation of the converse of the Pythagorean theorem. So the answer is yes. One more example. Is the triangle a right triangle? Justify our reasoning. I put this one in here because it has the square roots, and oh my goodness, what do we do when we have a square root? Well, I am going to look. I know that this square root is close to 16, which would give us 4. So this is a little less than 4, which is less than 6. And then 21 is close to, oh, its closest is 16 as well. No, its closest is 25, but that puts it less than 5. So I know that this is less than 4 and this one's less than 5, so both of those are less than 6. That tells me that this is my c squared. I can evaluate those square roots and know, but we've talked about how important it is to be able to estimate your square root and take what you know about the square roots near it so that you don't have to know the decimal. Plus, I don't want to work with the decimal when I go to plug in to my equation. So square root of 15 squared plus the square root of 21 squared. And when you square a square root, that's the inverse operation. So that just, this math is easier if we do it without the decimals anyway. And we want to know, we don't know if it's equal. We want to find out, is it equal to 6 squared? So the square root of 15 squared is just 15. When we square a square root, tongue twister there, we get what is inside. So when we square this square root, we get 21. So the square root of 21 squared is 21. And then 6 squared is 36. And then we're going to take 15 plus 21, and we end up with 36. So 36 equals 36. And so is this triangle a right triangle? The answer is yes, because the square root of 15 squared plus the square root of 21 squared is equal to 6 squared. That is our reasoning. So basically, we're still using the Pythagorean theorem. The difference is that we know all 3 sides of our triangle. We're trying to prove that this is a right triangle. So either they come out that a squared plus b squared equals c squared equals our largest side, or it doesn't. And if it does, if it's equal, then it's a yes, this is a right triangle. If it's not equal, it's a no, this is not a right triangle. It really is as simple as that. So until next time.